Hi again. I will continue my presentation about quality analysis of additively manufactured metals to give the outline of the book. So what I discussed about is what is the area of focus, and I mentioned that novelty of information is important for us in this book, but also learning about the subject. I gave an example of the available books in the market who present novel information, but maybe not so much suitable a resource for graduate and postgraduate student to learn about the subject. Then I will present one book which is very good resource for learning about the process and for understanding process, but is not presenting very novel information. This is the book Designed for 3D Printing and by Bernier, and it gives basic information about the method of model preparation and process parameters for 3D printing. In chapter 4 it gives 3D information on 3D modeling. In chapter 5 it gives information about drawing. Chapter 6 is about articulate, and chapter 7 is a process setup. So in this book you learn about additive manufacturing, but the data is not so novel. Of course, it is very useful for the users everywhere, students or anybody who want to use additive manufacturing and 3D printing, but not for an engineer and not for a graduate or postgraduate student. So what we want to do is not to go into this direction. If you are invited to write a chapter, for example, on a software, we do not expect to have a manual of the software in the book and learn the students how to use the software. On the other hand, the other point which is mentioned in the review process of our book was by one of the reviewers was that it would be very useful if you have some kind of open source or demo version of the software, which students could practically play with and have gained some experiences with that. How that simulation or how that modeling tool or how that optimization tool help in making a better process, and what is the improvement and what is the result. And it is if it would happen, that would be a perfect case. I know that for some of the softwares it is not possible, but if there would be some kind of demo version or some kind of video about how to use the software and what is the result of the software and how the result could be used, it would be very much useful for the students to know about the process of using the software presented in the book. I want to mention one good practice, one good example of the chapter, which present also novel data, but data which is not so much novel, and I believe it is a good source for a student to learn about the topic. And it is by Ian Gibson, Additive Manufacturing Technologies, 3D Printing and Rapid Prototyping. Especially I want to mention in chapter 10 they will discuss about direct energy deposition process, and they will in this chapter they will introduce the process. They will talk about powder feeding, wire feeding, DED systems, means the student will get a knowledge about how does it work. It is not so superficial, but it gives a very important information to the student, to the audience of the book. Then it goes a little bit deeper. Process parameters. How does the process could be modified? Which parameters is important in the process? And then it goes once again deeper to typical material and microstructure. And it describes different materials, different microstructures, maybe different defects in the structure, and it will give a very good information about process, structure, properties, relationship, how these three come together to make the property of a material or of a product. So this chapter is one of the best chapters which could be used, and for many of the experimental chapters, we use this model and make it detailed. What information could be presented in the experimental chapters, and at the end they will discuss about direct energy deposition benefits and drawbacks. So it is one of the good books on this topic. One point that I want to mention is that when, for example, when we discuss about direct energy deposition and we want to review it and we want to come to a material and we want to come to a microstructure and defects, so for any material, for example, in titanium or stainless steel or any other material, this may change, and this may, for sure, it will change, and we will have new information. So in the chapter for direct energy deposition in our book, the focus would be on one specific material. It will be the domain of materials would be introduced, but the focus would be on one material, and one material will be presented as the point of focus to talk about the microstructure, micro defect, process, structure, properties, relationship, and so on. So if we want to talk about the chapters, it includes in three main sections. The first section is fundamentals. So in the first section, we talk about AM process, about the AM process for metals, and about the quality of product. And we will review also the quality standards in one of the chapters. So how does the quality would be measured? Geometrical tolerances, mechanical properties, fatigue properties, defects inside, pores inside, what are the indicators of quality, and what are the methods of quality, analysis of a product made by additive manufacturing. So in the fundamentals, we will review all these topics. And then also in the fundamentals, we'll discuss about microstructures, micro defects, and the standards in micro and defects for additive manufacturing. We have ASTM standards, and we will review those standards for this book to give an idea to the audience that what is going on generally in this subject. So then we come to a more detailed chapters about experimental investigation. We try to go over all the processes available for additive manufacturing of metals. And then we try to cover at least one material in each process. Maybe if we come to the good candidates, we make it two or more materials in one process, but our preference is that we would focus on one material in a process, and then we go to the defects. Also, we will discuss about post-processing and what could be done after the process. Then there will be a lot of experimental investigation and experimental data will be presented in the second section. And we select just a piece of those data for predictive simulation on residual stresses, on microstructure, on geometry optimization, and so on. So these are mainly the whole pattern of the book, means make it more specified and bring it to some. Each chapter would be possible, which would be possible, we try to define some kind of activities for the students. And we think about activities, and we make the student search and dig on the subject and learn by him or herself. I hope this information would be useful for you. We have some key dates for these projects. The first list of contributors is due in March 2021, and then a sample chapter should be one sample chapter should be provided in May 1st in 2021, and 50% of manuscript is due on October 2nd, and the final chapter submission should be on December 2021. If you think you have some topic to discuss about or some chapters to be presented, please do not hesitate to contact me, and I'm very much looking forward for your contribution, and thank you very much for watching this video.